Have you ever wondered how an app goes from just a tiny side project to a global service that millions of people use every single day? I mean, every time you scroll through a social media feed or stream a video, you're using a system that started small and had to figure out how to handle massive, massive growth. So how on earth do they pull that off without everything just crashing? Well, in this explainer, we're going to pull back the curtain and show you exactly how it's done. We're going to follow the journey of our own hypothetical startup, and we'll build its system from the ground up, piece by piece, to see how you actually design something for massive scale. All right, let's get into it. Here's our roadmap. We'll start at the very beginning with just one server and a dream. Then we'll hit our first big growth spurt and figure out how to handle the traffic. After that, it's all about speed, so we'll look at caching. Then we'll take our app global with multiple data centers. And finally, we'll put all the pieces together to build our million-user machine. Every big idea has to start somewhere, right? And in the world of tech, that somewhere is almost always one single server doing absolutely everything. Your web app, your database, the whole shebang. It's all just humming away on one machine. And you know what? It's great. It's cheap, it's simple to manage, and most importantly, it gets your product out there. So your app is live. But there is a huge vulnerability hiding in plain sight. This image here perfectly shows the Achilles heel of this setup. It's what we call a single point of failure. I mean, think about it. If that one server has a hardware issue or just gets overwhelmed with users, your entire service, poof, it's offline. For a brand new startup, that's a total deal breaker. Okay, so the dream is happening, you're getting users, which is fantastic news. But that success brings your first real challenge. Your little server that could? Well, it can't anymore. It just can't keep up with all the new traffic. Pages are loading super slowly, maybe even timing out. It's time to evolve. Seriously, imagine this. You wake up, check your phone, and your app has gone viral. It got featured on some huge blog. Thousands and thousands of people are trying to sign up all at once. Your single server is buckling under the pressure. This is it, your first real scaling crisis. So what's your first move? You bring in your first hero, the load balancer. The best way to think about it is as a traffic cop standing in front of your application. Instead of all the requests trying to cram into one server, the load balancer intelligently spreads them out across a whole group of servers. And the best part? Now, if one of your servers goes down, the traffic cop just reroutes everyone to the healthy ones. Your site stays up, and you can just add more servers as you grow. And this is one of the key lessons in system design. Scaling is basically a game of whack-a-mole. You solve one bottleneck, and another one immediately pops up somewhere else. So now your web servers are handling traffic like champs, but they're all hammering the same single database, which is now slowing to a crawl. The problem has just moved deeper into the system. The solution here is called database replication. Basically, you create copies of your database. You have one master database that handles all the writes, all the new or updated information. Then you have multiple slave or replica databases that only handle read requests. This splits the workload, which is great for performance, but it also gives you a crucial safety net. If your master database has to go offline for some reason, the replicas are still there to serve data, keeping your app running smoothly. All right, so our system is way more stable now. It's reliable. But with all these new users and all this data, it's not feeling quite as snappy as it used to. So the next frontier for us isn't just about staying online, it's about being fast, really fast. This is where we introduce a cache. The classic analogy is a librarian who keeps the most popular books right at the front desk. Instead of running all the way to the archives, which is our database, every single time someone asks for that data, we store our copy in a super fast, easy-to-access memory layer. This takes a huge load off the database and makes the app feel instantaneous. And if you want to see why caching is such a superpower, just look at these numbers. It is mind-blowing. Accessing data from main memory takes nanoseconds. A random read from a disk, we're talking milliseconds. That's a performance difference of several orders of magnitude. By avoiding the disk, you make your application absolutely fly. But what about your users on the other side of the planet? The speed of light is a very real bottleneck, and that's where a content delivery network, or CDN, comes into play. It's a global network of servers that caches your static files, like images, videos, and so on, geographically close to your users. So a user in Japan gets the website's images from a server in Tokyo, not from one in California. It makes the whole experience feel fast for everyone, no matter where they are. Now that we have a global audience, a CDN for our images isn't quite enough. We need to bring our entire application, the brains of the operation, closer to all of our users. This means we have to move beyond a single region and start building a truly global infrastructure. So, the next big step is to build out multiple data centers. Our architecture is getting much more sophisticated now. We might have one complete copy of our system on the US East Coast and another identical one on the US West Coast. Each one is a fully functional replica with its own web servers, caches, and databases. And how do users get to the right data center? Well, there's a clever service called GeoDNS. It just looks at where the user's request is coming from, anywhere in the world, and automatically directs them to the nearest data center. This not only minimizes lag, but it also acts as an incredible disaster recovery tool. If the entire East Coast data center goes offline, all the traffic can be failed over to the West Coast automatically. So as we're pushing towards that 1 million active user mark and beyond, our system needs a new design philosophy. It has to be decoupled. Now, that sounds technical, but the idea is pretty simple. We need to break our system into smaller components that can work and scale independently of each other. That way, if one part gets slow, it doesn't bring everything else down with it. You know what? Let's up the stakes. We're now planning for 10 million daily active users. At this kind of scale, a single slow process, like, say, generating a video thumbnail when a user uploads something, could have a ripple effect that degrades the experience for everybody. We need a way to handle these heavy tasks asynchronously, outside of the main flow. The tool for this job is called a message queue. It basically acts as a buffer or a shared to-do list between different parts of your system. A producer can add a message or a job to the queue, and then a consumer can come along and pick it up and process it whenever it's ready. The key is they don't have to communicate in real time. This slide gives us a perfect real-world example. When a user uploads a new photo, the web server doesn't sit around and wait for it to be resized and filtered. No way. It just drops a quick "process this photo" message into the queue and immediately tells the user, "Yep, upload successful." Then, a completely separate fleet of worker servers can pick up those jobs from the queue and do the heavy lifting at their own pace. This keeps the main application feeling incredibly fast and responsive. Finally, when your system gets this complex, you just can't manage it manually anymore. You absolutely have to invest in visibility and automation. You need centralized logging so you can find the needle in the haystack when an error happens. You need metrics to give you a real-time dashboard of your system's health, everything from CPU load to how many daily users you have. And you have to have automation for testing and deploying code, or you'll never be able to ship new features reliably. And there you have it. We did it. We've evolved from that one simple server into a globally distributed, decoupled, and resilient system. Each step along the way, adding the load balancer, replicating the database, caching data, going global, using message queues, every single one was a crucial building block in creating an architecture that's truly ready for millions of users. But of course, the journey in tech never really ends. Once you've solved for 1 million users, a whole new set of challenges just appears on the horizon. How do you analyze petabytes of big data? How do you start integrating machine learning to personalize the experience? And what does it take to scale from 1 million to 100 million users? The core principles stay the same, but the problems just keep getting bigger.